Welcome to this day's lesson. We shall be looking at revision on the chemistry of the periodic table by trying to tackle a few questions. So look at this question. So this is a sample of a periodic table that we can use to answer a few questions from it. You can take a moment, pause the video and copy it on your end so that we can keep on referring to it. So the first question on the same clip asks, write the electron arrangement of element C. So from the diagram, you can see that we have C on this particular region, and therefore, if you were to draw the electron configuration of element C, you must be able to ensure that you know the atomic number of C. And how do you know the atomic number of C? You remember that the atomic number increases. This is how we label our periodic table. We have 1, we have 2, we have 3, we have 4, we have 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14, we have 15, 16, 17, 18, 19, and 20. So when we have it that way, we can be able to say that element C is has an atomic number of 14, and therefore to write its electron configuration therefore would be the first energy level would have a maximum of 2 electrons, followed by 8, and then now 8 plus 2, that is 10. We are remaining with 4 electrons, then we can have 4. So that one now gives us the electron configuration of element C. We look at the next question. So the question number 2 is that on the grid provided, show with a tick the position of element D whose atomic number is 18. So we need to select the position of an element that has an atomic number of 18, and therefore we use the same method. You know that this one is, we have position 1 here, so we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 18. And therefore, this is now the position of an element D that has an atomic number of 18. So you can just show like that, or just draw that this is the position where we have element D. The next question is explain why element E. Can you locate element E? We have element E here. Why element E is more reactive than element A? We have A here. So, and the one common thing with those elements is that those elements are all in group 2 of the periodic table. And to explain the reactivity of metals in group 2 or any other metal is that the ease at which an electron is lost is what now makes a metal more reactive than the other one. So comparing E and A, we can be able to mention that the ionization energy for element E is much lower compared to the ionization of A. As a result, E is more reactive than A. Also, you can explain by mentioning that as we move down the group, the reactivity or reactivity of metals increases down the group, and for that reason, E becomes more reactive than A. The next question is, with the reason, compare the atomic size of A and B. So now we look at A and B and try to compare A and B. And where is our A? we have A here, we have our element A here, and we have element B. And the question is now, between A and B, which one has a bigger atomic size? And the answer is A has the largest atomic size compared to B. Why? As we move across the period, there is increase in the atomic number. That means that the number of electrons, the number of protons for B is higher than the number of protons for A. For example, we can see that ideally A, the atomic number of A is 1, 2, 3, 4. So the atomic number of A is 4, while the atomic number of B is 4, 5, 6, 7, 8, is 8. So that means that A has 4 protons, while B has 8 protons. If we were to draw the electron configuration, or simply we can use the atomic structure for A, it would appear like this. We would have the first energy level having 2 electrons, and then the second energy level having 2 electrons as well. But then if you were to draw the atomic size, the atomic structure for B, it would look like this. We would have B here with the first energy level with 2 electrons, and then the next energy level with a total of 6 electrons. So you note that the number of energy levels is the same, so we cannot use the energy levels to explain the atomic sizes of A and B. But then the fact that B here has got very many protons means that it attracts the electrons towards itself more than A does. Or in simple terms, the nuclear charge in B is much higher than the nuclear charge in A due to the more number of protons. So for that reason, you find that B will be able to attract the electrons in the outermost energy level towards itself more as compared to A, and that results to the minimized size of the atom. So as we move across the period, from the left moving to the right, the size of the atoms do decreases. Are we good? We can check the next question. Select from the grid which element is stored in paraffin in the laboratory and explain. So the answer for that one is M. M is an alkali metal, and alkali metals are very reactive. You cannot leave them exposed in air. They will just react with oxygen in the air to form their oxides. So M being sodium, potassium, and even lithium are usually stored in paraffin in the laboratory, so as to ensure that to keep them from reacting with the oxygen in air. So for that purpose, we can just mention and say that M is the one that is stored in the laboratory under paraffin or in paraffin, and that is to ensure that they do not react with air or moisture in the air. And then next, select an element which can form an ion with a charge of +3. So remember that a charge of +3 is usually achieved or attained by losing 3 electrons. So if we were to look at the elements that we have here, the only element that can form an ion by losing 3 electrons is N. Why? let's check the atomic number of N. The atomic number of N is 1, 2, 3, 4, 5. So if it is 5, that means that its electron configuration is 2 is to 3. That is for N. And therefore, for it to react, it is easier to lose the 3 electrons than to gain 5 more electrons to form an ion. So for that case, we can say that N is the element that can form an ion with a positive charge. We look at the next question, and the next question reads, write an equation for the reaction that takes place when A and B react. So where is our A? We have A here, which is a metal with an electron configuration of 2 is to 2. So we can maybe begin by writing that element A with an electron configuration of 2 is to 2. And then we asked now to write the equation that takes place when it reacts with B. So we check B. Where is B? B is here. And what is its electron configuration? The electron configuration of B, because it is atomic number 8, its electron configuration will look like this. So we have B here with an electron configuration of 2 is to 6. So therefore, we can note that the valency of A is 2, valency of A is 2, and the valency of B is also 2, because it reacts by gaining 2 electrons. This one will react by gaining 2 electrons, while this one will react by losing these 2 electrons. So writing the equation for the reaction between the 2 elements, remember that we start with the element that is losing the electrons. So the formula will be we have A, which is a solid. We react it with B, and remember that B is a diatomic gas. So we have B, we have that 2 there, which is a gas. The equation will lead us now to forming A, B. Remember, we are getting this B from this. If we were to look at to write the formula of the compound that is formed when A and B are formed, this one is just a reminder. We take A and write it valency there. Then we have B, we write its valency there, and then we interchange the valencies. So when we interchange the valencies, we form A, 2, B, 2. But then now these 2 and these other 2 can just cancel out, and that is why we are just being left with that. So basically this is the formula of the compound that is formed when A and B reacts. But then we need to check whether the equation is balanced. Of course it is not. So we have 2 B's on this side. We can try to balance by having a 2 here, so that now we have, remember this one is, this is solid. We have 2, and then we can also have another 2 here on the A, and the equation is just balanced. Okay. Next question is explain why group 1 elements are referred to as alkali metals. Group 1 elements, and an example of a group 1 element in our case here is M, the one that we have here. We are saying that they are referred to as alkali metals because when they are dissolved in water, they form strong alkaline solution. That is question number 1. We can try to look at another example. So we have this second grid, and the first question is give the common name that is given to elements belonging to the group that is shaded here. And the name for those elements is the transition element. They are called, or they are referred to as transition elements. And why are they called transition elements? It's because they are usually placed there because they cannot fit elsewhere in the periodic table, and the reason it's because they have more than one oxidation numbers. An example of such an element which is in the periodic in the transition element is iron. Iron, you have heard of iron 2 oxide, and also you have also heard of iron 3 oxide. Iron 3 oxide. So iron 2 oxide, the 2 that we mention here implies the oxidation of iron, which is 2, or iron 3, the oxidation in this case it is 3. So because now they have more than one oxidation numbers, we cannot have them in any other place in the periodic table, and as a result they are placed in the transition elements. Another good example is copper. You have heard of copper 1 oxide and copper 2 oxide. Copper has the ability to have an oxidation of 1 and also an oxidation of 2. As a result, when it is like that, we call them transition elements. Such elements are just called transition elements. So they are called transition elements. We look at the next question. The next question is select element which belong to the same chemical family. So remember that elements to belong to the same chemical family, it means that they have the same chemical properties, and elements can only have the same chemical properties if they belong to the same group. So the only elements that are in the same group that can have the same chemical properties and as a result become members of the same family are the elements that we have here in group 1. So G, K, and J are elements that belong to the same chemical family, and that chemical family is called alkali metals. Then the next formula is write the formula of the compound that is formed when L and I react. So we have L and I reacting. The first question that we need to ask ourselves is what is the electron configuration, or what is the valency of L, to be able to write the formula of the compound that is formed. And from that one we can begin by trying to get first the atomic number of L. So the atomic number of L is 12, and we get it from, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now that the atomic number is 12, it means that its electron configuration will be 2:8:2, and that means that its valency in this case is 2. Let's look at I. The next element that L is reacting it with I, and the atomic number of I is what? We have 1, 2, 3, 4, 5, 6, 7. Its atomic number is 7. So if its atomic number is 7, its electron configuration is 2. Let me use a pen. 2:5. So this is L and this is I. This means that the valency of L is 2, while the valency of I is actually 3. This is the number of electrons that it will gain for it to have an octet state. So we have L now and I, where the valency of L is 2 and the valency of I is 3. So to be able to write the formula of the compound that is formed, we just need to interchange these valencies like that. And when we interchange these valencies like that, we will have L. This 3 now comes here, and then we have I. This 2 comes down here, and that is the formula of the compound that is formed when L reacts with I. The next question. So the next question, you are told that you write the equations for the first ionization energies of element K. The first ionization energy for element K, and also the first ionization energy, the equation for the first ionization energy of M. You already given and told that you already told that yes, the ionization energy of K is 577 kilojoules per mole. 577 kilojoules per mole, and the ionization of M is 1194. For M is 1194 kilojoules per mole. So if you are to write the first ionization energy, remember that the ionization energy is the energy that is the minimum amount of energy that is required by an atom to lose an electron from the outermost energy level in gaseous state. So in this case, if we were to start with K, we are saying that it must be in gaseous state. We have K as a gas. It will lose an electron to form K plus, which is a gas, plus now the electron that is lost, and then you're supposed now to indicate that there is energy here. We've been told that energy is 577. 577 kilojoules per mole. 577 kilojoules per mole. You can write that one in a bigger screen. In your book, you can be able to write that one in just one sentence and the equation will be correct. And then we try to write now the same for the next element, which is M, which we are told that it is 1194 kilojoules per mole. So M again, the formula of M, we begin with that, which is in gaseous state, we lose an electron to form M positive, which is also in gaseous state, plus now the electron that has been lost, and then you write energy here is 1194 kilojoules per mole. Ensure that yours, if you write your equation, it must be in a straight line. I'm just writing it just below simply because the size of my screen is not as big as the size of your book. Then we look at the next question, which reads, select from the grid the alkaline earth metals. So from the grid, you're supposed to get the alkaline earth metal. And what is an alkaline earth metal? These are elements that belong to group 2 of the periodic table. And our group 2 of the periodic table, without a lot of struggle, I hope you know that this is the group 2 of the periodic table. And therefore, the only element that is in that category is element L. So L is the one that is an alkaline earth metal. Remember, these elements in group 2 are referred to as alkaline earth metals simply because they are naturally found on Earth. And then next question is, you choose between K and M. You see where we have K, we have K here, and then we have M here. You choose now between K and M, which one is a better conductor of electricity. Remember that electrical conductivity of elements depends with the electrons in the outermost energy level that are responsible for electrical conductivity. And as a result, K, the fact that K is in group 1, it has only one electron in the outermost energy level that is responsible for electrical conductivity, while M, because it is in group 3 of the periodic table, it has 3 electrons available for electrical conductivity. So the fact that M has more electrons available for electrical conductivity makes it a better conductor of electricity, and we can just conclude that M is a better conductor of electric current than K. And then the next question is you explain the difference in the melting point of magnesium and sodium. When we explain the difference in melting and the melting and boiling point of elements in the same period, remember that both sodium and magnesium are in period 3. The electron configuration of sodium has 2, 8, 1, and that of magnesium has 2, 8, 2. For that reason, magnesium has more protons that resort to having a higher nuclear charge compared to sodium. As a result, the atomic size of magnesium is much small compared to that one of sodium. So for that reason, student, the particles of magnesium are able to pack more closely. We are saying that sodium is much bigger, and then we have magnesium being much smaller. This is sodium, and then magnesium. The fact that magnesium atom is now comparatively smaller, its particles are able to pack more closely to each other, resulting to a structure that has a higher melting and boiling point than sodium. And automatically now, magnesium has a higher melting point than sodium. Yes, and that is all. We will be looking into more examples, but those are basically the questions that are very common in paper 1, both paper 1 and paper 2, regarding the periodic table. Watch the next videos so that you enlighten yourself more and acquaint yourself with the necessary information that you require to answer questions in your exams.